Okay, this is the last of our differential equations videos. So we're going to look at how we can actually find particular solutions for differential equations. So this is where we start with an equation which is of this form: a d2y by dx squared plus b dy by x plus cy is equal to f of x. The method for doing this is to first of all put it equal to 0, so put the whole equation equal to 0, and then the solution of this is called the complementary function. Now if you watch the last 3 videos, we looked at basically how we do this, okay, how we find the complementary function. Okay, so we call that the general solution of an equation of a dy by dx squared plus b dy by dx plus cy equals 0. Now we're going to look at how we find out when it's a wee bit different when it's got a function of x on the right hand side. Now this function of x could be a constant k, it could be constant k, it could be a linear function px plus q, it could be an exponential function k e to the px, it could be a trig function, maybe p sine x, q as cos 2x, or maybe a combination of the two, p sine 3x plus q cos 3x. So a solution of the differential equation of any of the forms of fx given above can be found by inspection, and this solution is called the particular integral. So what you would do, first of all, you'd find this bit up here, remember? This solution of this, put it equal to 0 and find out, and that was what's called a complementary function. And then you find a solution for f of x, and that's called the particular integral. And then your general solution is when you put those together. So your general solution is y, which is equal to your complementary function plus your particular integral. So I think there's no better way of doing it than actually just getting started. So we're going to look at an example here. So it says find the particular integral of this differential equation in the case where f of x is equal to a is 12. So we'll just go through them individually. So for this what we want to do is we want to try y is equal to k as the particular integral. Now if y is equal to k, then dy by dx is just equal to 0, and d2y by dx squared is then definitely just equal to 0 as well. So that means sub into, we'll call this thing equation 1, sub into equation 1, and you're just going to get 0 plus 3 times 0 plus 2k is equal to 12, and that means your 2k is equal to 12, which means k then is equal to just 6. So in this case, really easy, y is equal to 6 is the particular integral, and it's as easy as that. Okay, for part B, it asks us to solve this thing, or to find a particular integral whenever f of x is equal to 3x plus 5. So for this one, we want to try y is equal to ax plus b. Now we're trying that because our y was, I think it was 3x plus 5. Say your y had been 4x squared plus 7x plus 2. In fact, I'll get rid of that in the middle bit. 4x squared plus 2, just even. 4x squared plus 2. Your particular integral for that case then would have to have been, you would have been trying ax squared plus bx plus c. Now notice, there wasn't even a linear term here, but I had to put my linear term in as my particular solution, because when you differentiate, it will become involved. So that's really what we're doing. Okay, so therefore, if we do that, then our dy by dx is just going to be a, and our d2y by dx squared is going to be 0. So we're going to sub it back into equation 1. Equation 1 was d2y by dx squared plus 3dy plus 2y. So that was sub into 1, and I forgot already. It was going to be 0 plus my 3 dy by dx. So in this case, that's 3a. And then plus 2 of my y, plus 2 times my y, which is ax plus b. And I know that's equal to 3x plus 5. So it's a bit of a mess to tidy up. I'll have 2ax, I'll have 3a plus b, and I'll put those in a bracket, and that's equal to 3x plus 5. So you're just equating. So I'll just say equate equate the coefficients of x. So you have 2a, that's the number of x on your left hand side, is equal to 3, which means a equals 1.5. And then we'll just say equate, I'll just say equate the constant. So you've got 3a plus b is equal to 5. Pardon me, so a wee bit of working out then. That is 3 times 1.5 is going to be 4.5. 4.5 plus b is equal to 5. A wee bit of working out your b works out to be 0.5. So you can say your pi, really squeezing this in here, pi is y is equal to 1.5x plus 0.5. Have I made a wee mistake there, have I? Oh, I have made a mistake. Have a look. You can see here, when I multiplied in by this 2, should add 2 times the b. That should have been a 2b then, so that changes that to be 2b. And then here, that's going to be 2b. So 2b is equal to 0.5, which means b is equal to 0.25. So that was easy fixed. So you can see there, my answer is y is equal to 1.5x plus 0.25. Okay, the next one, we were to do the particular integral then, we're on to this one, when the right-hand side is 3e to the 2x. Okay, so for c, we're going to say try. I'm just going to write down my equation again because I've forgotten already. It was d2y by dx squared plus 3 dy by dx plus 2y is equal to then, and it would have been 3e to the 2x. 3e to the 2x. So here, we're going to try, in this case, I'm going to try y is equal to k e to the 2x. Now, notice this is very clever here. Your thing was e to the 2x. No matter what way you differentiate that, if you differentiate a function of e, the power bit always stays the same. So that's why we've got that, still got an e to the 2x. That's why we know to make that power the same. And therefore, if you differentiate, you're going to get dy by dx is equal to 2k e to the 2x. And also your d2y by dx squared is going to be equal to 4k e to the 2x. And then we're going to sub that into 1. And it becomes, and you can see I've written it down this time, that's 4k e to the 2x plus 3 times 2k e to the 2x plus 2 times my y, which is just k e to the 2x, and that is equal to 3e to the 2x. So what you've got here, you've got 4k plus 6k plus 2k is equal to 3, because I've just divided through by my my e to the 2x. You'll have 12k is equal to 3, so your k works out to be 3 over 12, which is 1/4. So we'll just say, so your pi is, and it's y is equal to 1 over 4 e to the 2x. Okay, and the last one, I think and hope that for this one, it was cos of 2x. I'll write down my equation again before I do this. So it's going to be d2y by dx squared plus 3 dy by dx plus 2y is equal to, I've forgotten already, is equal to cos of 2x. Okay, so for this one, I'm going to let pi be equal to, y is equal to, we're going to say, we're going to call it a cos of 2x, and then this is an important bit, plus b sine of 2x. All right, so you've got to be very careful with this one. Even though there's just a cos of 2x involved, you've got to put the sine of 2x, and the angle bit stays the same, so it's going to be 2x. All right, and you'll see how it works out. So dy by dx then, differentiate this, you're going to get minus 2a sine 2x plus 2b cos of 2x. Differentiate that again, you're going to get minus 4a cos of 2x and then minus 4b cos of 2x. And that's what you've got. And your equation 1 becomes, so when you sub it all in, your equation 1 becomes, hopefully I have enough room for this one, it's going to be minus 4a cos of 2x minus 4b cos of 2x, and then 3 times the dy by dx, so that's going to be minus 6a sine of 2x plus 6b cos of 2x, and then we'll have to go on to the next line, unfortunately, plus 2a cos of 2x plus 2b sine of 2x, and that all is equal to cos of 2x. Okay, right, so that's what you've got, this whole thing. So, oh dear, didn't mean to do that. This whole thing here is equal to cos of x. So what we're going to do, I'm going to say, is equate the terms, equate the cos of 2x. So I've got cos of 2x minus 4 of them. I've got also another, here. That should have been a sine there, sine of 2x. Oh dear, I made a mistake there. That should have been minus sine of 2x, so that's then sine of 2x there. Apologies. Right, so that's what you've got. So highlight that again, let me see it. So we've got minus 4, and then minus, or plus 6b would be the next term, and then plus 2a, and that just equals 1. So tidy that up, that's going to be minus 2a plus 6b is equal to 1, dot, 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 equation 1, you know where we're going here. And then we want to equate our sine of 2x. So you've got minus 4b minus 6a plus 2b is equal to 0, which means then a wee bit of working out, you're going to get minus 2b minus 6a is equal to 0, which means, I will say then that means minus 6a is equal to 2b. I'll say that means b is equal to minus 3a. So sub that into equation 1. Sub into this equation 1, and you're going to get minus 2a minus 18a, that was a 6 times a minus 3a, is equal to 1. And that works out to be minus 20a is equal to 1, so a is equal to minus 1 over 20. Therefore, your b also works out to be plus 3 over 20. So your pi in this case is y is equal to minus 1 over 20 cos of 2x plus 3 over 20 sine of 2x. Okay, right. Now what we're going to do is put these all together. Now, I've used the same example here again. It says find y in terms of x for the differential equation. So this, we have already done the pi bit. We've just went through that whole process in the last question. Okay, so we've already done that. So we're going to start with the general solution of this, or the complementary function, I should say, of this. So we're going to, for this one, we're going to consider d2y by dx squared plus 3 dy by dx plus 2y equals 0. So you just put that equal to 0 the right hand side. So then the auxiliary quadratic equation is, and we've seen the last few videos now, it's going to be m squared plus 3m plus 2 equals 0, which factorizes to be m plus 2, m plus 1 equals 0. So it's got roots of m equals minus 2 and m equals minus 1. So these are real distinct roots. So the first of your videos, part 1 video on your general solutions, we can say hence your CF is y is equal to a e to the minus 2x plus b e to minus x. Okay, Now, very importantly, folks, we've done the bulk of the work. Remember, we solved that thing in yellow earlier on. We found in the previous example, part D. We found the PI of that thing. So here, we'll say from D in previous question, the PI, it was equal to, y is equal to minus 1 over 20 cos of 2x. And I think it was 3 over 20 sine of 2x. Let me just check that, as you've seen me making too many mistakes already. Yes, and that is it. Okay, now, the general solution is, remember, it's your CF plus your PI. So the general solution is horrendous looking thing, A, e to the minus 2x plus B, e to the minus x. Then you've got that minus 1 over 20 cos of 2x plus 3 over 20 sine of 2x. Okay? Right. This is only the general solution. We've got to find, solve this thing. So you've got information. You know when dy by x equals 0 at x equals 0 and y equals 0 at x equals 0. So unfortunately, we've got to try and find the values of a and b here. So here, we know when x is equal to 0, y is equal to 0. That means 0 is equal to, put x equals 0 into that. E to the power of 0 is just 1, so that just becomes a. And then e to the minus x, when that's x is 0, e to the minus 0 is just 1 again, so that's going to be b. Then minus 1 over 20, and cos of 0 is 1, sine of 0 is 0, so that's what you get. I'm going to bring that across, and I'm going to say then just a plus b is equal to 1 over 20. And I'll call that equation 1, no reason why I can't call it equation 1. And okay, now we also know, we were told in the question that dy by x was equal to 0 when x was 0. So you've got to find your dy by x. So unfortunately, we've got to differentiate this. Now think about this, and you've got 4 opportunities to make a mistake here. So take care, and I will have to take care as well. So it's going to be minus 2a e to the minus 2ax minus b e to the minus x. And then differentiate cos 2x, you will get minus 2 sine 2x. So then that becomes plus 2 times 120, it's going to be 1/10 sine 2x. And then that's going to be differentiate your sine, you'll get cos. So that's going to be, so differentiate sine 2x, you'll get 2 sine cos 2x. So that's going to be plus 3 over 10 cos of 2x. And then we'll just say when x equals 0, dy by dx equals 0. So 0 is equal to minus 2a minus b. Sine of 0 is 0. Cos of 0 is 1. So that's going to be 3 over 10. So again, a wee bit of working out. You're going to get, bring the a and b across this time. 2a plus b is equal to 3 over 10 ... equation 2. Okay, right, you have your equation 2 and your equation 1. So in blue then, these two things are what we're going to solve. We want to solve these two things. So I'm just going to do equation 2 minus equation 1. And that's going to give you a is equal to 2/20, which is the same, of course, as 1/10. And then sub that in, sub into 1, and you're going to have 1/10 plus something. Your b is equal to 1 over 20, which means your b is equal to 1 over 20 minus 1/10. And what is that going to be? Your b is, oh, here have I made a mistake again. Right, let me just check that and see. I think maybe a mistake in my notes. I think that's right, what I have written down. So that is, my a is equal to okay, right, let's just go back here and just check that. Sorry, you subtract those. You've got your equation 2, oh, I've made a mistake here on that. Apologies. Right, let's see how easy fixed it is. Your equation A, equation 2 minus your equation 1 is 1 divided by 20, and then minus 3 divided by 10, and that is minus 1 quarter. So that is, that's going to be positive 1 quarter. So positive 1 quarter is your value for your A. Dear, oh dear. Right, sub that into equation 1, then you have 1 quarter plus your B is equal to 1 over 20, which means your B is equal to 1 over 20 minus 1 quarter. So 1 over 20 minus 1 quarter, and you get minus 1/5. So your B is equal to minus 1/5. So your whole thing, therefore, your solution of the differential equation is y is equal to 1 quarter e to the minus 2x minus 1/5 e to the minus x, and then you had minus 1 over 20 cos of 2x, and then plus 3 over 20 sine of 2x. And that is us done.